Okay, continuing on with example number 4. We are going to use the definition of a logarithmic function to evaluate each logarithm. Well, what is the definition of a logarithm? The definition of a logarithm is find the exponent. The definition of a logarithm is what is the exponent to which you raise the base to get 32. That's what the definition of a logarithm is. Now notice it says no calculator. So with no calculator means show your work, not I did it in my head. No work, no credit. Now, yes, some of these you can do in your head, but I'm not a mind reader, so I need you to write down what it is you're thinking. Now, the reason why it says evaluate is because these are expressions. Later on, it's going to say solve because they're going to give you equations. So we can turn this into an equation if you would like. You evaluate an expression, you solve an equation. That's what we're trying to find. So either way, your work is going to be using the definition. 2 to the what power gives you 32. Well, again, the only way that you can do this without a calculator is to be able to make the bases the same. So what is 32? So your answer would be 5. And there's your supporting work to get full credit. Okay, the next one. The log of 1 base 3. The log of 1 base 3. Evaluate that. Well, what does that mean? You can think it, you can write it. It means 3 to the what power equals 1. Is that possible? 3 to the what power? Well, any base raised to the 0 power is equal to 1. So 0 is your answer. All no calculator problems require work, even if it seems like it's common sense. Because common sense isn't so common. Next one. 4 to the what power equals 2. So again, with these problems that are no calculator, you have to make the bases the same. That's the rule that you need to follow. Okay? If you can do it in your head, you can write it down. So this is 2 to the second. Now remember, you're never going to make these bases bigger. And then that's 2 to the first. So using the 1-to-1 property like we did before, your answer is 1/2. Okay, and then the last one, 10 to the what power equals 1 over 100. No calculator means you can make the bases the same. Do you know what exponent is 1 over 100? Well, we know it's going to be negative, and it's -2. So your answer is -2. That's how you show your work for the non-calculator evaluating logarithms. Okay? All right. All right, so the next ones do require a calculator. Okay, these do require a calculator. And basically, we're going to learn how to use a couple different buttons. Now again, depending on which kind of calculator you have, they all have these buttons, scientific and graphing. You have a LOG and an LN. You have a 10 to the X and you have an E to the X. Okay, those are the buttons we're going to learn how to use. You also have an E button here if you wanted to do E raised to any. You can use this one and raise it to any power, or you can use this one. You could do 10 raised to any power, or you could just use this one, okay? So calculator problems are just typing them into your calculator correctly. So log of 25, whoops, is going to look like this. And it says round your answer to 3 decimal places. So these are really straightforward. It's an approximation because we're rounding. 1.398. Okay. Then we have the natural log, so we have to use the ln button of 0.34. 0 is really not necessary. So that is approximately equal to a negative 1.079 if you're rounding to 3 decimal places. Okay, now this is very important, so pay attention. Later on, we're going to be mixing all these different things together that we're going to be learning over the next couple of weeks. And when they get mixed together, that's when people get confused. So I try to keep things very, very simple, and I don't teach you multiple ways to do things. So if somebody else is helping you from another class, if you have a tutor, whatever, if you're watching videos, there are multiple ways to solve logarithmic equations. There's multiple ways to solve exponential equations. But to keep it simple and to keep everything consistent, memorize this. To solve a log equation, you have to recognize that you have a log equation. Write this down. To solve a log equation, you change it to exponential form. Change it to exponential form. And that's what you have to remember. To solve a log equation, you change it to exponential form. So let's do that. Remember, we've already practiced this. What's our base? 10 to the 2.014 equals x. Log form to exponential form. And now we're going to use our calculator. So again, you can do 10 raised to, or you can use the 10 to the x button. It doesn't make a difference, whatever you're comfortable with. So there is your answer, and you're going to round to 3 decimal places. So that is approximately 103.276. Next one. To solve a log equation, you change it to exponential form. Go ahead and change it to exponential form. Notice, everything that we have done in the past, we keep building on. That's why this chapter is so hard for people, because they fall behind. You need to stay on top of things. You need to ask questions. You need to do all of your homework, and you can't miss a homework assignment, because then you won't understand what's going on. So now, again, we can do e to the whatever, or we can use e to the x, whichever one you want. E raised to the -4 power, not -4, but -4. There you go. And again, if you are not practicing this on your calculator, you want to go back and make sure you can get these answers yourself. Okay, next one. To solve a log equation, you change it to exponential form. So 10 to the 0 equals x, and we don't really need a calculator for this one. So 10 to the 0 is just 1. 3 decimal places if you want, 0.000. Okay? So those are calculator problems, but the log equations require exponential form. They require work. These do not require work. These do. Okay, last, we're going to talk about the change of base formula, which says this. If you're taking the log of x to any base, you can change the base. Because on our calculator, we have an ln button, which is base e, and we have an log button, which is base 10. Now, there are calculators that will allow you, if you know how to do it, it will allow you to type this into your calculator and change the base on your calculator. But you're not going to do that because that's not the directions. It says use the change of base formula. You have to use the change of base formula. You can't just say, well, my calculator allows me to type that in, because I'm testing you on, do you know what the change of base formula is? Here's what it says. You can take the log of x divided by the log of b, the log of x divided by the log of b. You can change this to this, and you can change the base to anything that you would like. So since we have a base 10 on our calculator, one of the things that I could do is I could change it to the log of 15 base 10 divided by the log of 2 base 10. That allows me to change my base to base 10. So let's see what that answer would be. The log, now be careful if you're not going to use your fraction button. You need to put an n parenthesis here before you hit divided by, otherwise you're going to get the wrong answer. Otherwise, make sure you use your fraction. Divided by the log of 2. So if I round to 3 decimal places, that's going to give me approximately 3.907. That's if I change it to log 10. Well, I also have a natural log button here, so I could also change it to base e. So instead of a base 10, I could change it to base e. So again, the log of 15 base e would be the natural log of 15 divided by the natural log of 2. And let's try that one out. I'm going to use my, alpha y equals, I'm going to use my fraction bar for this one. So the natural log of 15 divided by the natural log of 2. I get the same answer. So take your pick. You want to change it to base 10 or you want to change it to base e. Either one is acceptable for your work. Okay? Completely up to you. So when we do the next one, again, it's log of 20 divided by log of 1/4. I'm going to use natural log just because it's one less letter to write, not that it's any better. Right? And then what would this one be? Natural log of 1.5 divided by the natural log of the square root of 6. That's using the change of base formula. That's your work. Then you can type it into your calculator and get a negative 2.161 and 453. So you can go ahead and practice typing those into your calculator and see if you can come up with those decimals. Okay, so again, make sure you show your work so you can get full credit. And that is the end of 3.2.